Hi guys. So in this video, I will be explaining about my Oracle experience. Okay, so I've given Oracle a few times back, I think few months back. So at that point of time, what were the type of question that were asked to me? Okay, so let me share my screen and let me show you what all questions that has been asked to me. I hope you can see my screen now. So a video actually comprises of both round one as well as round two. Okay, so both I have combined because in round two there were not much questions that has been asked. So I have combined both the rounds in this particular video. So let's get started. So first is round one, and then this question was asked to me as a first question, like what's the difference between Spring and Spring Boot? So it's very commonly asked questions, right? So in the case of Spring, it requires a lot of configurations that we have to do. Okay, we have to rely on XML as well, Java-based configuration as well, and Catalina properties for Tomcat server configurations. Those all things we have to do. We have to provide dependencies individually. Okay, it will not automatically get configured. Okay, and we have to manually do all the setup for the entire project. But in case of Spring Boot, there is a auto configuration feature which is already given to us by Spring Boot. Okay, and internal embedded Tomcat server is being given to us. So we don't have to configure anything in advance. Okay, if you want to exclude that, you can put it within the exclusion tag. Let's suppose you want to add Jetty server apart from Tomcat. So you can exclude Tomcat and then you can include Jetty server. For that, you can do like that. Okay. So it provides some sort of starter dependencies like Spring Boot starter parent. Okay. And it provides all sort of starter dependencies by default to simplify the common libraries. And we don't have to think much about how to provide a dependency for starter parent. Okay. Then it provides a default project structure basically, and the project setup becomes very much easy because it provides a ready-made template to us like how the Spring structure of your project will look like. So that's the difference between Spring and Spring Boot. Okay. Next set of question was when you should go for monolithic architecture and when you should go for microservice based architecture. So we have to understand here, like if the application is small, it is not that big, then always we should focus upon going for monolithic application. Why? Because microservice becomes very much difficult to manage at a higher level, basically. So if the application is very small, then you have just split it down across multiple services, then managing them becomes very much difficult, right? Each services are being understood by other developers, different developers. So managing it becomes difficult. So and debugging also becomes very much difficult if you are putting multiple microservices, which is of no use. Okay. If there is a requirement is of microservices there, when there is a very big functionality, let's suppose banking functionality. In any bank, if you go, all will be making use of, most of the banks will be making use of microservice architecture only because there are multiple functionalities involved across multiple services. Okay, so there can be a list of customers. So what kind of transactions customer will do? Okay, there is a variety of functions that occurs within the bank, like say opening saving account, opening loan account, opening demat account. There are various type of functionalities that has been there, right? So for that, for each and everything, there should be a notification as well going to bank as well as to the customer. For that, there should be a different kind of server. Okay, and sending the data across multiple server to multiple persons, whatever there is a transaction going on. So for that also there should be a separate microservice. So different functionalities leads to different microservices. So there actually microservice is useful. Okay, there you can't make use of monolithic because it becomes very much long, lengthy, and complex, and it becomes very tedious to understand to any new developers coming across and trying to understand the code. Okay, so architecture perspective from that we can say like monolithic, this is a single unified application that handles all aspects of the functionality. And for microservice, it's composed of multiple independent service. Okay, it is a possibility that all the services are not dependent on each other. Okay, until and unless they are communicating with each other. Okay, so each services handles a specific set of functionalities. For deployment perspective, monolithic architecture will be deployed as a single unit. Okay, so it becomes more and more challenging when more and more functionality gets added into that. Okay, so let's suppose you want to add one minor change. Okay, one if condition of certain minor changes you have to do at certain places. You have to deploy entire application in case of monolithic architecture. So it becomes very much time consuming, and the process also becomes lengthier. Okay, yeah, so each and every component is not required to get deployed because their changes were not there. but still we have to deploy entire architecture as a single unit. So that is very much challenging. But here in microservice, that is not the case. Each and every service you can deploy it individually. So if there is issue in, let's suppose, payment microservice, so you can make changes over there, you can make some minor modifications, and then you can deploy that particular microservice independently and separately. So that is the advantage. Okay, for scalability perspectives, it requires scaling the entire applications. So it becomes very much inefficient, right? Why will you should scale the entire application when only few part of that requires scalability? Okay, but in case of microservice, that is not the case. Each and every service can be scaled independently based upon their needs. Okay, so so that it becomes more granular scalability. Okay, it provides more granular scalability, and it is the advantage for microservice. Each and every services are not required to be scalable. Okay, few of them is required and few of them are not required. So we can provide scalability to particular services which actually require scalability features. Okay, so that is the advantage. And for development and maintenance perspective, monolithic architecture can become very complex and hard to manage, because the monolithic application which you have created today, it will not be the same in future. Okay, every now and then developers will be coming, they will be adding some or other feature. So maintaining that becomes very much hard. But in case of microservice architecture, it becomes very much easy. So that's why it's told like you should go for microservice when you can see that in near future there will be a lot of functionalities that can be added across multiple services, across multiple type of different vendors. So there can be a chance, if you think so before writing code only, you should think all these things: which design pattern we should go for, which type of architecture we have to think, which type of development functionalities, like there should be waterfall model or agile methodology. Those all things should be discussed beforehand, before actually going for development, because we have to undo the task and then we have to do it again. If you think at later point of time that whatever architecture we have proposed and we have gone further with, it actually is not working out. Okay, so before starting the development only, we should do this planning and all. I hope you got a understanding of it. So let's go to the next question. What are the disadvantages of using microservice? So this is a common question. Like for each and everything, you have to know about what are their disadvantages. For example, for Spring, what is disadvantage? Spring Boot disadvantage, Spring JPA disadvantage, Hibernate disadvantage, microservice disadvantage. Okay, what each and everything you should know some 2 to 3 disadvantage points, because they can ask it. Okay, so from complexity perspective, we have to manage multiple services, okay, across the entire server. So it becomes much more complex, and inter-service communication can lead to data inconsistency as well at times, because there might be a scenario like there are 10 services communicating independently. Okay, they are having communication, but you are not getting response. So to debug and trace the root cause of the issue, like from which microservice data didn't come, that becomes very much hectic at times. Okay, and deployment overhead is a very challenging thing. Basically, it requires more sophisticated development and such as Kubernetes to manage multiple services across multiple pods. Okay, and data management is there, like handling data consistency and transactions across distributed services can become very challenging, and it requires solutions that can be complex as well. Okay, so we have to be mentally prepared before actually going for microservice based development. Network latency can be there, like inter-service communication can happen over a network, and it may introduce network latency as compared to in-process calls. Okay, so there can be a chance that second microservice or third microservice returning data in a bit delayed time. Okay, so there can be a chance of network latency at that point of time. So communication may get delayed or may not happen as well. So that can be the problem. Okay, and increased resource usage as well. It is also becomes much and more challenging. Why? Because we are running multiple services across multiple and they are using computational resources as well. They are using more and more resources of our servers and infrastructure, which increases the cost basically. So these are basically the challenges that we face in case of microservices. So let's go to next question. Next question was this: how will you trace the exceptions in microservices? So, and for tracing the exceptions, what all things you can do? there are multiple things that we have to focus upon. First is distributed tracing. Okay, so we have to track the entire request flow, starting from the input parameters, which all endpoints it is going. Okay, and first layer of connection like front end controller. Then from there it is going to which all services, like there are multiple service IMPLs. We have to track across that, and then we have to understand like which all services it's communicating internally. So that particular service also we may need to debug there as well. So there's a distributed tracing is required across various services, and we have to pinpoint that exception. So we can make use of Jipkin for that. Okay. So there's centralized logging feature is also that can be used. Okay. So we can aggregate logs from all the microservices that particular microservice is communicating with. Okay. And we can put it across a centralized location. And from there, we can see like where is the actual issue. So from there, you can find out what is the root cause. Okay. So there will be a centralized logging where all the microservice logs are coming at one place. I hope you are getting the point. Third is health checking and metrics. Okay. So continuously we have to monitor the health of the particular application. So here you can make use of actuator, you can make use of Prometheus, you can make use of Grafana, you can configure that, and then you can provide it in the authentication part as well. While doing the authorization, there you can provide the matchers for that, like which particular matcher you want the authorization, and then you can provide the actuator configuration, and then you can see after running up your Spring Boot server and having that URL with /actuator defined in the configuration. Accordingly, you will see that what is the health status of your project basically. So whether it's up or whether it's down. So if it is up, it's fine. If it is down, so you have to work on it. Like where is the root cause and from why it is happening like that. Okay. So with health check and metrics, like with respect to actuator and all, with the help of that, we can see the health metrics basically. I hope you got the concept in this. And last one is error reporting and monitoring. So with the help of certain tools like Sentry and Datadog, we can actually automatically detect and report certain kind of exceptions in real time. Okay, in real time. When it is happening at that point of time only, you can report this. So Sentry is what? It's basically a log reporting tool. So in this, basically whatever kind of exceptions are coming, whatever kind of log details are coming, it will be reported in this particular tool. Okay, and whatever kind of exceptions and errors will be there, it will be reported here, and you can make use of it. And in Datadog is a monitoring tool. Basically, it will keep on continuously monitor your application, like from where actually the issue might come. Okay, it will keep on monitor your application as well. Okay, I hope you got the concept. Then the question was how microservices communicate with each other. So it's a very common question, right? How microservices are communicating with each other. So basically there are two ways. So first way is through synchronous communication, and second way is through asynchronous communication. Okay, synchronous communication, basically we are making use of REST template. We are auto-wiring the REST template, and then we are calling exchange method. We are passing the URL and the request data, what actually that microservice is asking for, and then we are getting the data with get body, and then we are making use of it. That is the synchronous way of communicating. And asynchronous way of communicating is with the help of RabbitMQ or Kafka. Okay, so that is the way of communicating between the two microservices. I hope you got it. Next question was, what's the difference between application.property and application.yaml file? What's the difference between the two? So it's a most commonly asked question. So application.property, you can see like they will be equal to sign, like there will be a key value pair kind of thing. So both needs to be Spring. That is very much important. But in YAML, that is not a case. Okay, so there is a proper hierarchical structure that you have to maintain, and it can have data in the form of object. It can have data in the form of list or map or anything. The map the value part is not necessarily to be string. It can have any data type. So that makes it more simple and easy to understand. But the hierarchy should be very much maintained. If you're not maintaining the hierarchy, if the indentation is not proper, then there's a chance that you might get your server might not get restarted. Okay, your server might show some issues with respect to properties file. So you should know like how to do the indentation, from where we need to give how much spacing. So that hierarchical structure you should know beforehand how to make that hierarchical structure. Okay, so application.properties is less readable for very complex configuration because the structure becomes very flat, and same kind of words if you are repeating again and again 10 times, it becomes very much complex, right? But in case of YAML, you are writing the repeatable part only once, and non-repeatable parts you are writing across multiple lines with proper indentation. Okay, so there is a nested hierarchy which is going on. Then for complexity handling perspective, the application of properties becomes very much cumbersome when there is deeply nested configuration. You are repeating everything on each and every time, and one property is being changed. So you are just appending that property and rest part is remaining same. Okay, the handling, complexity handling is becoming very much cumbersome. Okay. In case of application.yaml, it becomes very much simple to handle nested and complex hierarchical configurations. Okay. And it very much cleanly configures what all data you are configuring over there. And data type for application.properties, I've already told you it accepts string values. Okay. And key and value both should be string. And in case of YAML, key will be string and value can be anything. Okay. It can be of object type. It supports complex data structure like list, map, etc. Okay. I hope you got a clarity on this. So next question was service discovery. What is service discovery? So service discovery is basically used in case of microservice where we have to register all the services first with the help of service registry, and then service discovery basically it discovers what all services has been registered in the service registry, and based upon that it delivers the data across multiple microservices. Okay, so there actually service discovery works when that particular service is already registered in the service registry. Okay. So authentication versus authorization is a very commonly asked question. So authentication means you are authenticating the particular user, whether it's the right user or not. Okay. So whenever there is a new joinee or there is a new person coming to the company, so that particular person needs to get authentication first so that they can put the ID name and password to enter into the website. But there can be a chance that few website that particular person is not able to access still after authenticating. So that at that point of time, there comes an authorization. So let's suppose higher authority person are authorized to access certain website. So that particular website may not be having your access to access that. Okay, that particular website you may not be able to access, but you are authenticated to access all the general website of that company. So that is a difference between authentication and authorization. Okay. So validating input data. So this type of question can also be asked like, how will you validate input data? So there are multiple ways to do that. Either you can put it in entity layer or in the in DTO layer, basically request input DTO layer. So there you can pass like @email, then you can pass like @not blank, @not null, that you can put across fields. So it will make sure that all the input parameters which are going are having proper data or not. Okay. Then you can have @valid annotation across the request body in the parameter of that method. Okay. And then you can create one certain exception class, like exception hierarchy class, and then you can provide that exception like empty input exception kind of exception. You can create your customized exception, and then in the REST controller advice class you can make use of exception handler, okay, within that method, and you can throw that exception when you can see like particular input is wrongly sent. That particular type of data should not be sent in the input. So like that you can validate basically your input data. So next question was, have you worked upon Kafka or not? So if you have worked upon Kafka, you can tell, or if you have not worked, you can tell like you have worked on different kind of thing, but you haven't worked on Kafka. It totally depends upon you and your project. What all projects have you worked upon? Next question was, what's the difference between JDBC, Spring JDBC and JPA? Okay, so JDBC, you know, right? There are 5 steps basically. Load the driver, get the DB connection via driver, issue SQL query via connection, and processing the results, okay, for the returned queries, and then closing all the JDBC objects. So these are basically 5 steps that we have to perform for Spring JDBC. But in case of Spring JDBC, we have to write the exact query. Whatever query you are writing in case of MySQL or Oracle SQL, the same query you have to put it here, okay, in a method. So that is the disadvantage in case of Spring JDBC. You need to know SQL query. If you don't know SQL query, then you can't proceed ahead with Spring JDBC. First, you have to know MySQL queries, how you are writing that. Then those native queries can be used in JDBC. Okay. So it's basically a lower level API which provides direct access to the resources with raw SQL queries. Raw SQL means a native query which you are writing in MySQL. Okay. So we have to manually handle all the SQL transactions, and it offers good control over SQL queries what we are writing. Okay. So it may increase the complexity because multiple joins and lot of things which you are writing in as MySQL, MySQL. Okay. So same thing you are writing in JDBC as well. So it increases the complexity a bit. But in case of JPA, JPA, it basically provides a layer of abstraction. Okay, it's basically a specification. I mean to say, Hibernate is a ORM tool, but JPA is a specification. It provides the layer of abstraction for interacting with the database. So it actually maps the data, the field values which is there in database with the Java objects, and then with the help of entity, table, those things, if you are writing ID to provide a primary key, those things if you are writing, it will map the field values of that table with the Java objects. And with the help of Hibernate queries, you can do the processing. So you may or may not be knowing SQL query, that's fine. But if you are writing Hibernate query, it will be at later point of time. Let's suppose you want to change the SQL type. Let's suppose you want to move from Oracle SQL to MySQL or MySQL to MongoDB at later point of time. So you don't have to go to your code and change the query, because in case of JDBC, you have to specifically tell like this is MySQL. Okay. But in case of JPA, you can write Hibernate query. Okay. And then it will work across multiple databases. Like if you are using Oracle SQL now, later you can change to MySQL. So then also it will work fine. Later you can change to MongoDB. Then also it will work fine. So JPA becomes much more loosely coupled basically. So that's why in industry standard, JPA is widely used. So I hope you got the clarity on this. Like what's the difference between JDBC and JPA? So this is the most commonly asked question, like if one of the services goes down, then what will happen? So if one of the services goes down, then basically you have to make use of fault tolerant mechanism like Hystrix and circuit breaker design pattern. Those things you have to implement, like resilience, 4J resilience thing you have to implement. Okay. So these all things you have to implement when the services goes down. So within that circuit breaker design pattern, how you will import the library for that you have to learn. Like from Spring Cloud, it will take the library files. Okay. And then there is open close concept is there, then completely open, completely closed. So those all things like half open, half closed, those concepts are there. So kindly go through those concepts. Okay. So those are very important concepts. And next question was, have you made use of Docker or not? So Docker and Kubernetes, these are asked at later point. Okay. So when they have asked all questions about Java, Spring Boot, microservice, then at last they will ask questions on DevOps, like have you deployed your application or have you built your application manually? Have you made use of Docker or Kubernetes, and what all those things? If you are confidently answering that, then they will go a little bit in depth. But if you are not able to answer properly, then they will understand like you have not worked much upon it, then they will move ahead. Okay. So it totally depends upon you and your project basically. Then what is a JavaScript? I was feeling like, why did this question was asked to me? Okay. Suddenly, all of a sudden, this question was asked to me. So you may expect basics of front end kind of thing. Okay. So this question was asked. So you may be able to answer this. Basically, it's type scripting language, and all to do all form of validations and all from the UI perspective, we can make use of JavaScript. Okay. So round two. So these was all from round one. Basically, if we are going to round two, they were mostly from project based. All questions mostly were from project based basically. So a few to one or two questions that was I felt important that I am putting it across over here, like the difference between entered table and entered entity. I have put it across over here. You can go through it. You can pause the video. You can go through the difference basically. Okay. So entered table basically, if you want to specifically provide a table name. Okay. If you are writing added entity, then if you are not writing added table, then what it will do? So database table name will be defined with the class name which you have defined in your Java. Okay. But if you are writing added table and providing the table name, so it will create the table based upon manually created what you have given there. Okay. It's customized table. So if you want to customize the table name, you can go with added table. And if you want to keep your table names same as your Java class name, you can remove added table. Basically, it's optional to write. But if you have seen the convention, basically, so table names are not following camel casing conventions. They are following underscore conventions. Like let's suppose employees there, so employee. Okay. So employee small, it will start from small basically. So if it is employee ID, it will be employee underscore ID. Okay, like that. Everything new words, if you are appending, you have to provide underscore for that. So that is the convention basically for naming in database. But in case of Java classes, it follows camel casing convention. So it's generally not followed to have the same column names which you are providing there as well as in the Java class. So we should be making use of added table, but we should be knowing that it's not mandatory. You can remove added table as well. So rest of the differences, you can go through it. Okay. I've already put it across for you. Okay, you can pause the video and you can go across. Next question was, is add a table mandatory? So no, it is not at all mandatory. Okay, so it's totally up to you. So if you want to provide your own customized table name, you can provide add a table, and you can provide a table name for that by name equal to providing the table name, or else you can leave it as it is. If you want to keep the table name same as class name, it's totally up to you. Okay. So next question was all based upon project based, like what all things have you worked upon in your project? What all tech stacks have you worked? And from functionality perspective also they were asking, like functionally wise in core banking based application, what all features have you implemented? So they were expecting some business functionality terms. So technical terms also and business functionality terms also, you should be knowing certain terms. Okay, like appreciation, depreciation. So few other terms are there. So I'm also not remembering as of now. So those terms we should be knowing from functional perspective, basically. So if you can able to answer that way, so you will be able to nail it, basically, because the second round was mostly of a hiring manager round. So they were expecting more of a business perspective. Okay, like what is the functionality? So you have to tell more from that perspective rather than technical perspective. Okay, so this was it for Oracle for round one and round two. I hope you got a clarity and understanding of it. So if you are going to give interviews for Oracle solution services, then you can go ahead and watch this video, and you will get to know all sort of question that has been asked to me. So we'll see you in the next video with next set of concepts. Till then, it's Dave G. Troy signing off. Bye bye.